All right, let's look at section 1.2, problem number 6. All right, let's solve this following initial value problem. All right, so dy over dx is given to be x times square root of x squared plus 9. All right, so let's take the antiderivative to find the y. So y is going to be equal to antiderivative of x times square root of x squared plus 9 with respect to x. Right? In order to evaluate that, I'm going to use the substitution. I'm going to let u be x squared plus 9. Right? So if you take the derivative of u with respect to x, you will get 2x. Right? And then I'm going to take the reciprocal of both sides. So you have a dx over du. And we're just putting every one upside down. So 1 over 2x. And then we multiply by du. So that the dx is equal to du over 2x. All right. So let's rewrite this integral here. So we have an integral, right? X. I'm going to leave this x as it is for now, right? Then we decided to call this expression inside the square root u. So we're going to have square root of u, right? And dx, we just found the dx to be du over 2x, so we're going to plug this guy in here to get du over 2x. Alright, let's clean it up a little bit. So you have, there's an x on top, there's an x on the bottom. Alright, then we can actually, there is the 1 over 2. So 1/2, this is just a constant. So I'm going to place it in front of the integral. So you have a 1/2. Right? Then we have an integral. And I don't like square roots, so I'm going to write it as u to the 1/2 power. Then you have a du. Right? Then we can take the antiderivative. So 1/2 is still there outside. Antiderivative of u to the 1/2 would be, by the power rule, add 1 to the power, so it's going to be 3/2. Divide by 3/2 is equivalent to multiply by 2/3. So I'm going to just put 2/3 in front. Right? Then you have plus some constant c. Right? Then we can simplify again. There's a 2 on top and 2 on the bottom. And then we can just put the original variable back in. So you have a 1/3 is still there. Right? Then u is originally x squared plus 9. And we're going to raise that to 3/2 power. Then we have a plus some constant c. Right? So that's the best we can do from just looking at the differential equation. Right? So let's use the initial value condition to find the value of c. Right? So we're going to say, let's see, y, and we're going to plug in -4. Right? So we're going to have, let's see, 1/3 is still there. Right? So we put -4 squared, it's going to be 16. 16 plus 9 is 25. And raise it to the 3/2 power plus c. Right? Let's simplify this. So this is going to be 1/3. Actually, let's see. 25 and the square root of 25 is 5. And you have to cube that. So it's a 125 over 3 plus c. Right? We know that this is supposed to be equal to 0. So we're going to set that equal to 0. All right? Then we can simply subtract 125 over 3 to get the c value. C is -125 over 3. Right? So therefore, we have the complete formula for the solution. Y is equal to 1/3 quantity x squared plus 9 raised to the 3/2 power and minus 125 over 3. Right? So that is the solution of the given initial value problem. Right? That's it. I hope that this was clear.